Good evening, everyone. We extend a warm welcome to all participants and distinguished guests as we commence the third day of our faculty development program, sponsored by AICTE on building predictive AI models for route optimization and emerging technology practices in smart manufacturing. We appreciate your continued presence and engagement, and we look forward to an insightful and enriching session ahead. Today's first session will be handled by Dr. Pradeep S. I request Ms. Kirtana to introduce the resource person.
Good evening, everyone. It's my honor to introduce our esteemed guest for today, Dr. Pradeep S., Assistant Vice President and Head of the Nest Digital Academy. Dr. Pradeep brings over 18 years of professional experience in capacity building, project management, marketing, and strategic management. He is widely regarded for his ability to drive organizational transformation and develop high performing teams through a stakeholder centric and client focused approach. He holds an impressive academic profile, including an MBA, MSc in psychology, PGDHM, PGDID, AFP, an advanced program in leadership from IIM Lucknow, and a PhD. His expertise covers soft skills training, leadership development, design thinking, product development, and strategy development. Prior to joining Nest, he served as the head of the retail training unit at the ICT Academy of Kerala for nearly 8 years and has expensive experience in the financial service sector in training, skill development, and marketing. We are truly delighted to welcome Dr. Pradeep S. as our guest. With great pleasure, I invite Dr. Pradeep S. to take us forward with his session. Over to you, sir.
Yeah, thanks, Kirtana, for the wonderful introduction. And thanks, SCMS Group, for inviting me, for giving me an opportunity to interact with the faculty members. And thanks all the faculties to join for this particular session. Okay. So before starting the session, I just want to have a quick understanding about the faculty profile. Okay. I'm sure that a lot of faculties are both from computer science as well as management. So you can put on the chat if you are from management, you can put M, and if you are from computer science or engineering, you can put E. Okay. So if you are from management, you can put M, or if you are from engineering, computer science, or arts and science, you can put E. Okay, I got a response from Marian. Okay, as M. How about others? Can you just respond? If you are from management, you can put M. If you're from computer science or engineering streams, you can put E. Okay, Sumita, Srinivas, management, Pradeep, engineering, through the engineering. Good. Basil, George, Thomas, it is engineering. Okay, Anjana, management. Okay. There's an interesting combination of engineering and management. Krishna Bhaskar, it is management. Good, good. Yeah. So thanks for your response. So that gives a fair idea about the participants' profile. So before starting my presentation, I just want to make it a bit interactive, and maybe we can have a lot of co-learning or peer learning also. So I would like to ask few questions. You can either respond in the chat or you can unmute your mic also. So let me start sharing the screen. Oh, my screen is visible, right?
Yes, sir. It's visible.
Yeah. So I'll be talking on something called innovation to impact. So basically, the agenda will be the business models in electronics manufacturing and why India needs innovation, especially in the manufacturing sector, and what are the types of innovation which is very common in manufacturing. And I'll also try to talk a little bit about rapid prototyping in software as well as hardware. Maybe my focus will be mostly into the software part. So I'm not an academician. I'm actually from the industry, but I have a strong interest and passion towards academy also. So the company I do represent is Nest Group. So if you are from Kerala, probably you may be knowing about Nest Group. So give a small introduction about Nest Group. So why I want to give a small introduction about the Nest Group, because that actually matches the topic for today's discussion. Okay, so basically we are a conglomerate, okay, with expertise in hardware design, software, and manufacturing. Okay, we have been in the system for last 35 plus years. So we deal with a lot of Fortune 500 clients with almost 9,000 plus employees. And we have a couple of factories and offices across the world. Okay. So basically, we are majorly into a business model called original design and manufacturing. And I'll just explain in detail. Okay, that is where the session gets started. So we are a diversified group under technology. We have multiple companies. I do represent from the technology side. I'm heading the learning and development of Nest Digital. I am also part of industry academy relations as well as campus hiring. So our major line of business is into manufacturing. I think around 80 to 85% of the business comes from the manufacturing, which is a larger unit with more than 7,000 employees. And we have a small vertical in education as well as in the foods and beverages. So that's a small profile about the company. So our products, basically, we focus mostly into the components, electronics manufacturing. Our products is exported to more than 56 countries across the world. And we do deal with some of the exciting projects for big companies and in aerospace as well as defense as well as in the healthcare. So that is where I just want to start. So I said our major model of business, okay, is into electronics manufacturing, and we focus on something called original design and manufacturing. Okay. So my first question, okay, you can have. So I will be talking from two perspectives. Of course, it's a manufacturing, since I having a bit of software as well as I do represent from an electronic company. Maybe I'll share mostly about electronics as well as the software examples. Okay. So, in electronics, India is growing growing exponentially big, and India is considered as or to be one of the giants in the electronics manufacturing. So in electronics manufacturing, we can see there are three kinds of business model. One is called OEM, one is called ODM, and one is called EMS. So I just want to understand from your view, what do you understand from OEM, ODM, and EMS? Either you can put on the chat or you can unmute your mic. So that is where I would like to start the session. So what do you mean by OEM, what do you mean by ODM, and what do you mean by EMS, which is very prevalent in electronics manufacturing? Can anybody share your thoughts? You can either put on chat or you can unmute your mic. Yeah, I can see if your chat's coming up. Original manufacturer. Okay. Good. So what is ODM and what is OEM? And there is something called EMS also. Okay, original equipment manufacturer. Good, Anish. Thanks for the response. What is ODM? and what can be the difference between these two business models? Okay, so maybe I just want to start with the thought process. So I'll explain in detail what is OEM and what is ODM. Okay. So OEM is something called original equipment manufacturing, and ODM is something called original design and manufacturing. Now, when it comes to India, we focus on both segments, OEM, ODM, and even there's something called EMS, Electronics Manufacturing Services. But predominantly, you can see these two models, OEM and ODM, where I will just give a little bit emphasis. Okay. So let us start with OEM. So what is OEM? Okay. So the core business model is to manufacture products for certain clients as per their design expectations and requirements. Now, the best example is Apple, right? So Apple is not directly involved in manufacturing of Apple phones. Okay. So one of the major manufacturer is Foxconn. You may be heard about Foxconn. It's a Taiwan-based company. And they were focusing mostly in China and Vietnam. Now they started focusing on India because there is some kind of the strategic relationship issues with China and US, and they want to diversify their risk. Okay, so they started their operations in India. Okay, so you can see a lot of opportunities are coming up in Foxconn. Yes, recently Foxconn established their manufacturing in Chennai as well as in Bangalore. So that is a maybe best example. Now, Samsung is actually into the both is electronic manufacturing services. They also manufacture electronic components. They also supply, okay, for example, OLEDs are displays to the competitors. Okay, so if you talk about a lot of the mobile phones and other TV manufacturers, and Samsung supplies OLED displays also. So there is something called Bharat FIs, which produce XI Xiaomi mobiles. So what is ODM? Now, when it comes to the pyramid, ODM actually stands above OEM. So what is ODM? So when it comes to ODM, the ODM creates product design and architecture and specification. Okay. Now, if a company does not want to spend a lot of time on the product design, and if they are actually outsourcing to another company, and if that company have a specific expertise in the product design, they can save a cost and they can save a lot of time also. So sometimes the companies actually try to give the outsourcing work to ODM because they can create the product design and architecture. So when it comes to manufacturing, it will be a complete production, assembly, and quality control under one roof. Now, one example is, I don't know whether you heard about a company called Dixon. Okay, so it is probably the largest electronics manufacturing company in India. Okay, so they actually design LED TV for almost all major brands. Okay, and there's another company called Compal, which designs laptops for Dell and HP. So they may be actually uses okay product design and architecture for multiple companies with a lot of changes. Now, when it comes to the major difference between OEM and ODM, okay. Now, when it comes to OEM, the client owns complete design and IP. If you talk about Apple, okay, so Apple outsources a lot of manufacturing and assembly to a lot of other companies, but when it comes to the design, when it comes to the intellectual property rights, it's actually lies with Apple. Okay, so Apple have a strong research and development team. They constantly work on innovation and constantly work on R&D, and they create great design, they create technology, and they try to source raw materials from a lot of companies. Even the company I do represent, Nest Group, also recently backed a project from Apple. So we supply a small component as well as we also provide a small software services for Apple. But for us, it is a very prestigious moment. Now, OEM is slower time to market because when it comes to the design, okay, the original the company have to spend a lot of time in the product design. Now, when it comes to the OEM, margins will be very less. So when it comes to OEM, it talks about the large scale of manufacture. So the company say that, okay, I will buy X, or I will buy X quantity of a particular components, and the margin will be less. And the client have a lot of restrictions, and the client have a lot of quality control, client have a lot of audits. And when it comes to ODM, the manufacturer owns design and IP. Okay. So the seller, I mean, the seller is actually the manufacturer. The seller actually owns the IP, and the margins will be very, very high. Okay. Because, since it involves the design as well as IP, and the manufacturer holds a lot of rights over the IP, okay, they can actually get leverage for these IPs also. So the margins will be very high. And the manufacturer also have a lot of autonomy also. So the company I do represent is, we focus majorly into ODM. Of course, we have an OEM model also, but our major focus is into the ODM. Okay. Now, when it comes to the global market, if you talk about global market of OEM and ODM, it is around 800 billion US dollars, and it is growing at around 7% every year. So Indian market size is also very huge, and India is also growing exponentially in the electronics manufacturing. So some of the top Indian OEM and ODM companies, as I said earlier, okay, Dixon Technologies, okay, which is one of the largest manufacturing companies in the electronics. And there are a lot of companies like Amber, Sigma, Optimus, Bharat, okay, even Nest is also may occupy top 10 OEM and ODM companies. However, these companies may not be very visible because they focus mostly into the B2B in the domestic market. They may not be very visible also. Okay. So when we discussed about these companies, I have observed that a lot of companies does not know about these companies because their primary business model is completely different. And another thing is, since they deal with the clients, okay, some of the times they will not be. There are a lot of restrictions in using the brand of the client. Okay, maybe disclosing what kind of products they make for the clients. Okay, a lot of confidentiality, lot of agreements are there. Okay, so one agreement is there can be an agreement where ODM player cannot be the original player. Okay, for example, now, we extensively work on medtech. Medtech in the sense, okay, the company like GE and Siemens, okay, they extensively manufacture the medical imaging equipments. Okay. So normally when these companies enter into agreement, they make an arrangement with the ODM, say that, okay, you cannot be a competitor, okay, to that particular company for the next 100 years, because after some time ODM will have a lot of capability, right? So they have a capability on the design, they have a capability on the electronics part. Some of the companies can be complete engineering. For example, they have a plastic molding and metal sheeting. So they themselves can produce a product and which can be direct competitor to these players. So there will be an agreement like that. So getting such kind of projects is not very easy. And currently, a lot of Indian companies, okay, because of their capability in their technology and because of the large availability of the manpower resources, okay, we are getting a lot of projects also. And so the primary business model for OEM is the manufacturing fees, assembly services, and component integration. So basically, it talks about economies of scales, long-term relations, and stable relationships. That is one of the advantage with OEM, because so once you enter into a agreement with the clients, normally client also does not want to move to another party because of a lot of challenges like, okay, quality and the confidentiality, right? So when you enter into a business agreement with such kind of clients, it will be a long term. For example, we do have a lot of clients which are been with us for the last 30 years. Okay, and we are getting the repeated business also. And when it comes to an entry, okay, the threat of entry to a new player is also very less because of the earlier reasons I have mentioned. And the thin profit margins, that is one of the major concern, and high capital expenditure requirements also, because manufacturing requires a lot of high investments, and some, especially on the electronics manufacturing. Okay, there's a concept like clean room where these electronics products needs to be manufactured under a conditioned environment. Okay, so the temperature, even the dust the temperature needs to be on a certain degree, and there should not be any dust. Okay, when you try to manufacture it, and even when you the people who are actually involved in the manufacturing or in the assembly, okay, they may have to wear a different kind of suit. Okay, where you, even our body have a little bit of energy, right? Okay, that can be actually transferred to the electronic devices. So there are, when it comes to the investment, it is a high capital expenditure is required. Now, ODM business model, okay, as I said earlier, okay, so the revenue streams comes from different aspects. One is the design and engineering fees, the intellectual property licensing, and manufacturing and assembling services. So basically, the margins will be significantly higher than an OEM, and there's a lot of strategic values there. So when it comes to investment, there is a substantial investment is required for R&D and design infrastructure, engineering talent acquisition. Since the product design and IP, right? Okay, so that requires a good talent, and that requires a talent with a lot of niche skill set. And the company like us, we find it very difficult to get such kind of talent. And there should be a substantial investment into the R&D. When it comes to an idea to prototype to finally, or a proof of concept to finally to the product, that requires a lot of time also. So a company have to invest on R&D, which will give you return on investment after long years. So that's a business model called ODM business model. So one case study is Foxconn, okay, which is the largest electronics manufacturing company. Okay, they have 1 million plus global workforce. So their product portfolio, they're one of the major customers. A major customer is Apple. Okay, so they manufacture different equipments of the Apple, and they also engaged in with Sony, as well as their manufacturing presence in China. India is the late entrant in their late entrants in this particular business, and Vietnam, Mexico, and Brazil. So Dixon Technologies, which is an Indian-based ODM manufacturers. So they actually leveraged on production-linked schemes or incentives by the government, right? Okay, so as per Make in India project, okay, there are a lot of production-linked incentives were given. Okay, and a lot of companies were able to leverage and capitalize on that kind of production-linked incentives. So when it comes to the Dixon Technologies, some of the major clients are Samsung, Motorola, okay, Philips, Panasonic. Okay. They have a lot of product ranges, from LED to smartphones to washing machine to lighting solution to security systems. And there they have a consistent year on growth of 40%. So, so typically, if you talk about the market trends in the electronics manufacturing, so a lot of companies having earlier it was focused on China, and now a lot of companies were actually diversifying their risk. It is like China plus one strategy. Of course, apart from China, have a lot of advantages, especially in the electronics manufacturing. So one is their government policies. Second, availability of technical resources. Then the most important is they have a lot of access to the rare earth elements, right? Nowadays, you might have seen in the news, right? Now China is trying to bargain, and China is trying to play the card with the rare earths, right? Now, when US was trying to impose restriction with China, and they are trying to play the card on the rare earth equipments. Even India is also facing the challenge, because almost 90% of the rare earth equipments, and not equipments, rare earth minerals are coming from China. even though a lot of other countries have rich natural resources of rare earths, it requires a lot of investment and requires a lot of time to refine and produce these kind of rare earths. So China is obviously having a bigger advantage over all other countries, but most of the countries, most of the companies are planning to diversify the risk. Then, electronics, it is, you have seen like the product life cycle of electronics products is coming shorter, right? So normally people wants to use new features. Probably after earlier we have used BPL and Keltron TVs for almost 10 to 15 years. Now after every 5 years, people try to change to a new models because a lot of innovations are coming, new features are coming up. So then a lot of explosion in the wearable technologies, for example, the smartwatch, other fitness trackers, that is also getting a lot of a lot of demand from the market and the policy support. So overall, if you talk about the electronics manufacturing, it looks very prospering. Okay, for India, India is positioned as alternative to China, even though we need to have a improve on a lot of areas. Okay. However, there is a significant jump in our electronics manufacturing. I think around 50% of the Apple components will be exported from India in another 1 or 2 years. Then IT hardware push, export powerhouse, and localization drivers. So these are the few opportunities for it. Okay, now SFO, which is a manufacturing division of Nest, which is also part of OEM and ODM, we are into medical devices, industrial IoT, aerospace, and telecom. Okay. So in short, my first part of the presentation is to just give an overview about the business models in electronics manufacturing. So we discussed about OEM business model and ODM business model and what is the fundamental difference between these business model. And we are talking about the market potential and India's trajectory and what is India's advantage when it comes to this particular segment. Now, we have seen when it comes to the employment opportunities, we have seen a lot of opportunities are coming for the people who can work on operator level. Okay, for example, company like Foxconn, they hire large number of people who can work on operator level. So people who have been who are having an ITI or diploma qualification have a lot of opportunity nowadays. Even for us also, SFO, okay, I think they must have recruited around 300 to 400 people who having an ITA as well as a diploma. So a lot of opportunities, employment opportunities are coming up for in this electronics manufacturing. So that's my first part of the presentation. I will just stop with this. Okay. So before moving to the next module or next section, I will stop. And if you have any questions, you can put on the chat. Then I will move again. Any questions? Can I move forward? Okay, I assume there are no questions. So my next part of the presentation will be the innovation which is happening in the manufacturing sector. So in this presentation, I will put it into two phases. The phase one is a very generic one, but that is also very important. Okay, we will be talking about why innovation is important, what are the different kinds of innovation. Then we will be talking specifically about what are the different kind of innovations happening in the manufacturing. Okay. So that is my second part of the presentation. So before starting the presentation, it's a very common topic and it is being discussed multiple forums, but I just want to understand from your perspective. So why innovation is very critical, okay, for any industry or for any company? You can put on the chat. I would like to have a bit of interactivity. It's a very simple question, okay? Why innovation is very critical? for the companies as well as for the different industry. Can you respond in the chat? Can somebody respond? Why innovation is very important? It's a very simple question, right? Yeah, I can see few responses pouring. Okay. Yeah, innovation make products unique. Very good. Innovation is a key driving factor which may also provide an USP to a company. Great. Good. Good. Thanks for all your responses. Yeah. So there are multiple reasons. So one is, I can see a few more responses for company growth said by Dr. Meera. So one is, the world is full of problems, right? And so the 5 years back, one of the major problem we had was the pandemic. And we thought that, okay, once we try to tame the virus, we thought that the biggest problem is been over. Now, after that, okay, we had another set of problems, right? The world had different kind of war, okay, Russia-Ukraine war, okay, then there was a conflict between Israel and Palestine, okay, and the global economy was also under a lot of turmoil, right? So we feel that, okay, once a problem is solved, we get a lot of relief, right? But we will set a new set of problems. Now, what Albert Einstein said that we cannot solve this problem with the same thinking we used when we created them. So we need to have a different kind of mindset. Now, second is adapting to the VUCA world. I'm not going to explain in detail. You may be like volatile, uncertain, complex, and ambiguous time. Now, third one is responding to increasing customer expectations and concept of value. So when it comes to there is some the concept of product life cycle. You may be knowing about this product life cycle. Okay, if you put in a graph, the vertical axis talks about sales and horizontal axis talks about the time. Okay, now every product, just like a human life cycle, it have a life cycle. Okay, starting from introduction to growth to maturity to decline. Just like a human, they started as an infant to kid to a children to teenage to middle age to the old age and to the death, right? Okay. Now what happened is this product life cycle of most of the products are getting shorter and shorter. So the customers are expecting a lot of new features and customers are looking for new concept of value. So that leads to a challenge for the company. So there are two challenges. One is the customers' expectations are very high, and the time to reach the time to implement the innovation is also very less for the companies. Now, I would like to share from a software example. Okay, I will share two big companies, which is a very popular companies. Just try to understand, okay, what is the business model difference between these two companies? Okay, and I will just try to connect with the innovation. So basically, what I was discussing is why innovation is very critical and why what are the different factors which can trigger the innovation. But I just want to share with one example about two companies. So you can see these two companies, Google and TCS. Okay, now if you talk about the important metrics of the companies, you can see Google is having around 1.82 lakhs employees and TCS is around 6 lakhs employees. Market capitalization is 1.7 trillion and TCS is around 200 billion. The annual revenue is, it's really amazing for Google. It is almost around 12 to 13 times that of TCS, even though they have only 1.82 lakhs employees. The revenue per employee is 1.78 million, and whereas TCS is 47,000 US dollars. So I don't want to compare the company. So each company have its own strategy, and each company is good in its own strategy also. Now, what can be the fundamental business model between these two companies? So why Google was able to get more revenue, more market capitalization with less number of employees? Can somebody share in the chat? So let me repeat my question. So we have seen very important metrics of two companies. One is Google and TCS. And my question is, what is the fundamental difference in the business model between these two companies, Google and TCS? Can anybody respond? What is the fundamental difference? Why? Yeah, I'm getting some responses. Yeah, Naveen Prabhu, great. Google is a product-based company, and TCS is a software company. Okay. Now, the reason I just shared a slide is, if you talk about Indian IT industry is facing some challenges. One is obviously when Trump comes into the picture, a lot of restrictions on H1B visa. Then it is being also said that okay, there can be some kind of tariffs will be will be done for the IT exports also. So one is the global market for Indian IT companies are not really look very attractive compared to the earlier years. If you talk about the IT stocks also, they are not also performing really good, right? Now, the okay. Now, when it comes to because of AI, the lot of the labor arbitrage model is also getting affected, right? Now, earlier, when it comes to the TCS, the business model works with labor arbitrage. Okay, we say that okay, for developing a particular product or service, there we need an X number of employees. Okay, now with the advent of a lot of Gen AI tools like GitHub Copilot or Claude or Cursor, you can generate a lot of code, and code can be deployed, code can be developed and deployed, okay, with the support of AI models. So earlier, IT companies used to hire freshers on large numbers. They need a large army of coders. Okay, now we talk about the snippers, okay, where they can do a smart work by writing few prompts, and they will be able to generate and deploy the codes. Okay. So if you talk about the IT hiring and okay, fresher hiring scenario, also the numbers are drastically coming down because the current labor arbitrage model of Indian IT services is getting disrupted. So we have to move to the value chain, okay, the value chain of just providing services to a product companies. Now, thanks all the IT companies learning and try to move to a product space also. We had few companies when it comes to the product companies from India, we had only few companies, right? Even though India is the largest exporter of IT across the world, we export more than what Saudi Arabia export oil across the world. Okay, IT exports is we are a powerhouse in IT. However, okay, when it comes to the products, we have very handful of companies. One exception can be Soho, right? So product companies or product actually brings a lot of revenue. Products have a very huge scope for generating revenue also. So I mean, the reason I said is the innovation. Okay, so the innovation makes a lot of impact when it comes to the revenue or profitability of the company. So this is the business model of service and product based. Okay, business model of services, client based projects and contract. Product is always proprietary products. Revenue sources is billing for services and it is product sales. So for services based company, it's more forcefully focused on delivery and client satisfaction, and for product, it is innovation and product flexibility. So since you are in the academia, so I just since I'm supporting the company, the campus hiring also, so I closely watch different trends of different colleges, how does their placements works. So this is an interesting scenario of IIT Bombay. So last time, okay, they had the placement was not really great, and they had a big salary range difference. Okay, so one the highest salary was around 1.5 crores, and the lowest salary was 4 lakhs crores. So just try to think from this perspective. Okay, if you want to get into IIT Bombay, there will not be major difference in their the entry gating, right? So it can be a 0.01 percentage determines whether a person's entry into IIT Bombay or some other lower ranking IITs. But when it comes to output, there is a huge difference between the range of salary, right? One guy is getting 1.5 crores and another guy is getting 4 lakhs crores. Now, if you talk about people who got the highest salary brackets, mostly these people will be either into the R&D or are into the product development. So the people who having a product mindset or innovation mindset, okay, or higher order thinking, okay, they can demand more salary. So that is the role of innovation. Why innovation is very critical. Okay, so if you talk about India, this is a global innovation index. Switzerland ranks first, and India is almost on the 40. I just want to share one more example why innovation is so critical. Now, Nvidia, which is the largest company in the world when it comes to the market capitalization. So Nvidia's market capitalization is 4 lakh trillion. Okay, now this Nvidia's market capitalization can be compared with India's GDP, and India is it is the fourth largest economy in the world. So that's a power of innovation which can actually generate the market capitalization for the companies. Okay. So you can just imagine, okay, a lot of African countries, okay, they may not come even closer to Nvidia. So that leads to something called creativity, innovation, and innovation. Okay, now the targets of innovations are expanding product, services, operations, manufacturing, and in management. Now I'll just focus on what are the different kind of innovations, and I will just focus mostly into the manufacturing innovation. So typically, if you talk about innovation, innovation can be divided into product, process, marketing, and organization innovation. These are the four major categories of innovation. So product is very simple, the significant improvements in the technical specification, components, and materials. Okay, that leads to something called product manufacture. Now, process innovation. So what is process innovation? So this involves implementation new or significantly improved methods of production or delivery of the product. Now, just want to start, okay, which is the fifth largest economy in the world? Just can you just give a guess? India. Okay. India is the fourth largest. Now it is estimated that another 2 to 3 years, India will be the third largest economy also. Which is the first one? You can rank it 1 to 5. You can put on the chat. The first one is very easy, right? It is US. So can you just put 1 to 5? Which are the countries? China, Japan. Okay, good. Yeah. So it start with US, then China, then Germany. Okay. India. Okay. Then Japan. Okay. So Japan is the fifth largest economy in certain parameters. Okay. Now, Now, if you talk about Japan, okay, now Japan as a country had a lot of disadvantages, right? Okay, now what are the disadvantages Japan as a country? I just want to connect with something called process innovation and manufacturing innovation. Then I will have a detailed explanation that. So, what are the challenges Japan as a country have? So Japan as a country have a lot of disadvantages. One is they have less natural resources and their geography is very smaller. And if you talk about Japanese geography, maybe around 70% of the Japanese geography is either mountainous or it consists of islands. And they have a highest life expectancy and they find it very difficult to mingle with other people because they are not very favorable in understanding the other languages also. And after the Second World War, Japan was completely devastated, right? Despite all these disadvantages, Japan is one of the most powerful economies of the world. Okay, and Japan is having a very great reputation of high quality products. Right? If you talk about Japanese and German products, it is of significantly high quality. Normally, we have a lot of reliability on these kind of products, right? Now the reason is if you talk about the largest why Japan becomes so powerful. Now they had since they had a lot of desire, especially after the Second World War. Okay, they actually tried to optimize their production process. They thought, okay, since they have everything less for them, okay, with the less resources, financial, be it a human resources, how they can optimize their manufacturing meanwhile without compromising anything on the quality. So most of the Japanese companies try to observe a lot of process which is being developed in different countries. Okay, and Japan was one country which actually borrowed a lot of process from US also. Okay. Now, you know, which is the largest, you may be knowing that Toyota is the largest car manufacturing company in the world, and especially after the Second World War, Toyota was almost bankrupt. Okay. Now, these Japanese companies are not able to afford the expensive mass production facilities. Okay, and so they want to reduce wastage and low cost automation. Okay. So what they did was they have developed something called Toyota Production System. So they came out with a lot of concepts like just-in-time manufacturing. So rather than having a large-scale manufacturing or large-scale the where keeping a warehousing, they actually go into a process called just-in-time manufacturing. So whenever they find there's a huge demand for a particular product, they start sourcing the raw material, then manufacturing, followed by the manufacturing process. Okay. So they came out with a lot of concepts like zero breakdown, zero inventory, zero delay, zero accidents, zero defects. Okay. And they implemented something called lean manufacturing system, and they implemented a lot of philosophy or process, which helped them to optimize their manufacturing process without compromising on their quality. So borrowed system, you know, Maruti Suzuki, obviously their parent is Japan, okay? So they have implemented JIT, Kanban, Kaizen, okay? For example, TVS implemented Kaizen, then Tata Steel implemented Lean Six Sigma, okay? Bajaj and Ashok Leyland also implemented Lean methodologies, and which is implemented across different parts of the world also. So these are very simple marketing innovation, which is you want to make some changes in the product. Organization innovation is you want to make some changes in the organization policy that organization become very agile as well as very competitive also. Okay. Now I just want to focus on the manufacturing innovation. Now the innovation can be further divided into radical, incremental, disruptive, platform, open, and frugal. So let me share with an example. So radical innovation, which talks about breakthrough innovation that fundamentally change manufacturing. You know, for example, the 3D printing, right? So it was actually pioneered by MIT as well as GE. Okay? That actually, especially the GE Aviation, they came out with 3D metal printing. Then when it comes to the Tesla, the EV manufacturing. So rather than they actually rely on a lot of suppliers. They actually acquired a lot of important critical components supplies. For example, when it comes to the critical component of EV is the battery, right? So they have actually integrated a lot of suppliers and becomes an integrated supply chain unit. Space manufacturing, Indian ISROs, they are very famous for the low cost models. Okay, so that's a radical innovation. Incremental innovation, so it is like continuous improvements. So for example, Toyota, they have a policy called Kaizen. Okay, so Kaizen is a Japanese word. Now Japanese people believe that, okay, the major breakthroughs can come on the consistent, smaller and incremental improvements. You might be read a book called Atomic Habits, right? So if you want to make major changes in the life, make sure that you put a small consistent efforts over a period of time. That will have a power of compounding. Now, what Toyota do is, okay, in the shop floor, okay, or in the manufacturing floor, okay, they always try to seek ideas from the people, and it is being said that around 60% of the ideas which they seek from the employees, because employees really know what is the real life challenges, right? So it is they made sure that, okay, making small changes on a daily basis will actually have a huge impact on the long term. Similarly, Tata Steel and Mahindra also did the same. Now, there is something called disruptive innovation. So when it comes to disruptive innovation, these are some of the technologies that replace the traditional manufacturing models. Okay. For example, there's something called additive manufacturing, replacing the traditional casting models. Okay. So earlier there is something called tool and die making. Now, because of additive manufacturing, it is actually replacing the traditional casting methods. So robotics, maybe you might have seen the warehousing automation of companies like Amazon, okay, where the most of the products being handled by the robotics, okay. So that is something. Now, BYD EV battery technology. Now, one of the biggest competitor for the Tesla is BYD, because the heart of any EV is the battery. Now, BYD was earlier is very famous for building battery. They are one of the pioneers in the battery technology, because the BYD was supplying, and BYD is also now supplying the batteries for the mobiles, right? So they have a lot of expertise in the battery technology, since they have a access to the rare earths elements from China. Okay, so BYD is actually putting a lot of competition for Tesla. Now, another example, I mean, it is not related to the manufacturing, the Netflix, right? Okay, so when Netflix was started, their business model was delivering DVDs and VCDs to the home. Okay, Blockbuster was the market leader. So slowly after Netflix understand that people try to leverage internet for the entertainment. So platform innovation, so this is one great example, okay, shared platform across multiple products. When it comes to Tata Motors, Tata Motors had a very bad reputation of not a great build quality, not a great technology, right? Now, so what happened, Tata Motors have acquired the big companies like Jaguar and Land Rover, right? And they actually have a lot of access to patented technologies, a lot of platforms. So what they did was they actually bring that platform and try to implement it in Indian market. If you talk about the Nexon or Punch, okay, so most of these platforms are actually borrowed from the Jaguar Land Rover that actually transform the Tata Motors fate. Okay, so there are some platforms which can be shared across multiple products. For example, Foxconn, that is one of the greatest advantage for the ODM. Okay, so they may create some platforms, and these platforms can be actually shared with multiple companies. For example, in Nest also, okay, we created some platforms that will be shared across different competitors. Okay, so the cost can be really reduced also. So one great example of platform innovation is, the Apple. Like, so rather than they actually rely on the external platforms, they have something called backward integration. If you talk about the hardware, software, even the Apple iOS, right? Everything is mostly developed by the Apple or its OEM. So they don't actually rely mostly on the external people, okay, which is actually patented also. So, I mean, that is why Apple phones have a seamless integration, because all these hardware, software, content, software, I mean, everything is aligned, and this is specifically used for Apple. So it's a classic example of backward integration. Now, another innovation we can see in manufacturing is frugal innovation. Now, what is frugal innovation? So typically, the people have a perception that when you want to innovate, when it comes to innovation, we have to invest significantly in the lot of functions and features of a product. But however, a customer may require only few core functions. Maybe one example I just want to share is my mother recently purchased a fairly expensive smartphone, and if I really check her usage, she mostly used for taking pictures and do a video call or take a photographs. Okay, she does not use 90% of the function. So can we think about creating a product which focus only on the core function, so that the complexity and cost can be reduced? So when it comes to manufacturing, Tata Nano, okay, they came out with a very affordable manufacturing model, so low cost ventilators. Okay, these are some of the examples. Okay, now another example is the refrigerator made by a person called Mansukh Prajapati. It has been estimated that around 20% of the Indians are able to afford refrigerators. So if you ask about the need for refrigerator for people in the rural families, so comparing to people in the urban areas where both the people, I mean husband and wife, will be working, and they may not be able to spend much time in the kitchen, right? But when it comes to the rural areas, so the requirement for the refrigerator will be like, if they actually prepare the food and if there's a spill over the food, they want to keep the food for another 1 or 2 days. Okay, so this refrigerator is actually created with the our the traditional clay methodology, clay technology. Like, it does not require any electricity also, and this costs around 1/13 of the modern refrigerators. So there is something called open innovation. So what do you mean open innovation? So there is a research conducted that when it comes to the key sources of innovation, okay, what are the key sources of innovation? So the as per the survey done by Grant Thornton, okay, it said that the biggest source or great source for innovation is the customers, because the customers are the end users who can share about a lot of problems about a particular product, right? So then only the business units and employees, in-house R&D and CEOs could come. So open innovation is you collaborate with external partners. Okay, it is called co-creation of a product. Okay, so you collaborate with the customer, you collaborate with the suppliers, you collaborate with the distributors, and you try to bring some kind of insights from these stakeholders. So there are a few examples: Siemens, Tata Motors, Maruti Suzuki. Okay, now another few. I mean, the great example is IKEA. IKEA is the largest, the manufacturing. They are very famous for their design as well as the cost effectiveness. So IKEA, they closely connect with customers. They have a community. They have a platform. They will seek ideas from the customers, and they try to co-create the product. So I mean, this is one classic example. Lego, right? Okay. So, and at one point of Lego is the largest toy manufacturer in the world. Okay, and one point of time they had a challenge of, okay, their market share. So they start engaging with the kids, and they start getting ideas from the kids that leads to the development of a new product. So this is what they call as open innovation. Now, these kind of, I mean, when it comes to manufacturing, the innovation, these are the four pillars. One can be the customers, employees, technology, as well as the organization philosophy. So these are some of the key characteristics of innovation. I don't want to spend a lot of time. And there are a lot of barriers to innovation is also. For example, organizational resistance to risk, okay, inability to measure innovation impact. So in short, okay, we have seen four major buckets of innovation, and we have seen the further subdivision of innovation that is specifically applied in manufacturing, and this can be applied in other sectors also. Now, which can be called as great innovation. So an innovation, these are the three important parameters for a great innovation. One is business viability. When you create a product, okay, it should generate revenue for the company, or it should maybe as a synonymous, it can be a social sustainability. At least it should sustain itself. Technological feasibility, it should have a great technology and people should accept it. Now, even though Tata Nano was I would call it a frugal innovation. They are able to bring the product at a lower cost, but it was not accepted by the customers because way they positioned this particular product. Okay, they positioned as the cheapest product in the market, right? So the people acceptability was not less and was not great. So, in India, buying a car is considered the social status and symbol. Okay. Yeah. So Asha raised the hands. Asha, do you have any questions?
Sir, in the case of Tata, it was not only this one, like that came later. The customer were against the product that came later. But earlier, the thing is that everybody started booking Tata and like it was against the same products of Tata. Tata was not was having a competitiveness from this one. That also was there. So the company had to slow down because other cars were not having the same market. That was the initial problem. Later on, then when the people were using it, once after 1 year only, the customer came to know that okay, these are the problems. That tires were like different, front tires, back tires are different. The making that also is not that much what they say reliable.
Yeah.
That is the
Yeah.
thing.
Yeah. True. Yeah. Thanks for this concept. So yeah, so that is another challenge. Okay, so one is initially the product. I mean, they didn't do a proper testing, and product had a lot of glitches and technical challenges. But later on, they moved very fast and they try to address the problems. But the image when you take a Tata Nano was okay among the public was not so great. Okay, I mean, and the people who want to purchase this Tata Nano car, okay, so they feel that okay, their social status can get degraded. So that was one reason for failure of Tata Nano. Thanks, Asa Madam, for bringing it out. So now the last point, I know I have less time. So the last point is now when it comes to the manufacturing, when it comes to creating an innovation in manufacturing, there are a lot of phases in innovation. I'm not going to explain that. Maybe one phase of innovation is creating a prototype. I'm sure that you may be knowing about prototype. So prototyping is creating a small model of a product. So um, I'll be talking a little bit about prototyping, or we call it as a rapid prototyping, if you want to fast track the innovation. Of course, when you want to develop innovation, you need to understand the needs of the customers, create ideas, shortlist the ideas, then move to the prototyping and then do the testing. So the last part of my presentation will be talking a little bit about rapid prototyping, which is used in manufacturing as well as in the software services. So, the prototyping, this is a very common model for prototyping. Now, when it comes to prototyping, there's a concept called fidelity. What do you mean fidelity? Which is a degree of exactness which something is copied or reproduced. Just for an example, okay, I'm from Trivandrum, okay, and there is a gray market. I mean, especially for the foreign goods. The place is called Bhimapalli. So if you go to that particular place, you can see a lot of foreign products, which looks, or even the look and feel looks like an original product, but there will be a small change in the spelling or the design of the logo can be different. Okay. So some are able to produce something which is as original, okay, which can be easily copied or reproduced. Now, when it comes to fidelity, these are the different phases of prototypes. Okay, you can have a prototype or proof of concept for both for manufacturing as well as software also. So maybe I'll start with the software part. So on a vertical axis, this is called fidelity. The more fidelity, it will take more effort and cost. Okay. So there are 4 phases like sketch, wireframe, visual mockups, and prototypes. So what is sketching? So sketching is very simple. You take a piece of paper, you try to draw a design, and you try to iterate. You iterate further. Okay, so that's a sketch, and that is pretty and cheapful also, right? So what in the wireframe? So that is also a low fidelity layout that serves three purposes. That presents information on that can be displayed on the page. It gives an outline of structure and layout of the page. It conveys overall direction and description. Just want to give a very simple example. Earlier, okay, when we want to construct a house, we go to architect and we say that this is the some requirements in our mind, right? So based on understanding our requirements, the architecture may create the design of the house, right? And it will be full of a lot of specifications, right? It will be, they say, 330 into 300. Okay, that can be the room size, and it is very difficult for the layman to visualize that. So basically, wireframe is trying to create a layout or structure of a particular software or a product. Now, nowadays, if you go to the same architect and if you share your requirements and needs, okay, so what they do is they capture this requirement, they create a wireframe, then they will try to put it in a visualized format, right? So they will try to create a 3D imaging. Okay, I've seen when I want to when I was intending to purchase the flat. Okay, so they create some so visual. I mean, with a lot of AR VR technology, you'll be able to enter into a room. You can visualize the color. You can visualize the space of the room. Okay. So similarly, when it comes to the software, also we can create visual mockups. Okay, that combines the real website as plus app. It will work on a real browser and it will work on a smartphone also. So earlier, okay, if you want to create a visual mockups, you should have been able to understand a lot of front-end technology and back-end technologies. Now you can create a visual mockup with some tools. I'll just demonstrate a tool towards the end. Okay. So this is a software part. Now, when it comes to the hardware, typically, it start with concept sketch prototype. Again, okay, you can have a 3D sketching. Okay, a lot of 3D models are there where you can create a sketch. Then you take some specific function and you try to focus on that specific function. You try to integrate different features, structural components, electronic integration. So the result is you will get a physical model, okay, that may match the size and function of the final production. Then this may not have any visual impact. So you try to create a UI, okay, when it comes to the visual model, where you try to put the model of the product also. So this will help us to have an understanding about final product look, material, and form. Now it may be given for testing for the internal stakeholders, and based on the feedback, they will create an alpha prototype. So that will have a features of, or most of the features will be incorporated. The physical part will be 3D printed, CNC machine, and cast using production intent geometry. That will be done. Okay. So the purpose is to validate and verify the function. And this may be tested on a limited basis with the external customers also. So based on the input, okay, they will go to the next phase, which is called the manufacturing phase. So in fact, there are a lot of tools are there which can actually help us to create a proof of concept at a faster phase. Now, I just want to share one example with a tool. This is a very simple tool. Let me share the screen. Okay. Now, this is a tool. This is a prototyping tool or visual mockup tool. This is developed by Google. Okay. Now, I just want to create a UI for a particular product. Now, assume that when it comes to the electronics, it involves both aspects, right? UI and UX. Okay, it involves a lot of electronics, and the UI is also very important. Now, I want to create a very great UI for a particular product. Suppose I want to create a home-based ECG machine. So I can create a prompt like I want to UI home-based ECG machines. So this is a simple prompt I want to give. Now, this particular tool is thinking a little bit. So based on that, okay, they have shared the different steps: welcome screen, device pairing screen, ECG reading dashboard, reading details, and profile set. So I think I'll go for all of these features. So this is assembling different components. Just wait for a few seconds. Yeah, it is getting generated. Just wait for another 20 seconds. So nowadays, if you talk about creating a UI of a product, or if you want to create a proof of concept, okay, so with Gen AI tools, you can easily create a prototype. So that is what we call as rapid prototyping or fast tracking a product development. Just normally, Gen AI tools will take some time in creating the images. In the backend, it is doing a lot of process. Yeah. So you can see there is something called this is it is creating a lot of UI. Now, one advantage is you can integrate this particular with other tools like Figma, okay, and you can generate options also. You can edit it. You can export it, you can download it. And even what you can do is, if you want to get the backend code, okay, you can get the backend code also. You can have a mobile view, you can have a tablet view. So you can see the code, right? Okay, basically this works on HTML. You can see the code, you can copy the code, and you can actually put in the real HTML platform to develop further. So what I'm saying is, so this is basically UI. Okay, so we also do a lot of UI for the lot of electronics product, and this will be integrated with the hardware components also. So the nowadays the product development can be done very quickly. Okay, if with the use of Gen AI tools, and there are some very really great tools are available which will actually fast track the production. So this is one great tool. It is called Stitch. So now let me go back to the final slides. So I mean, so what I'm saying is there's something called accelerating innovation with rapid prototyping, the speed to market, risk mitigation. Okay, you can have a lot of early testing, and you can understand the failures from that particular product, and it's very cost efficient also. So a lot of, for example, in hardware, okay, there is something called 3D additive manufacturing, CNC, laser cutting, vacuum casting, PCB rapid prototyping, a lot of technologies which help in rapid prototyping. So even software also, we have seen a small demo of how the software prototyping can be done, okay, with a faster pace. So the last part is now the changing landscape in the manufacturing. So second part, the third part, I was focusing on prototyping, how the rapid prototyping can really help the manufacturing. So the last part is what is the changes happening from manufacturing. So earlier, manufacturing, the key competency or key competitive advantage is you have a large infrastructure, okay, with a large manufacturing facility that requires a huge investments with a great infrastructure. Now the companies are moving from this is called static automation, legacy systems, okay, minimal flexibility, and high capital investment, locked configuration. So that is moving to hyper flexible automation drives, which involves a lot of AI enabled adaptations. You can rapidly making changes. So that's the advantage of OEM and ODM. Okay, they can manufacture products for multiple companies, and they can make a lot of changes very fast. And there are a lot of advanced technologies and mass customization is possible. So these are the some technologies. Okay, for example, collaborative robots. It is not fully autonomous robots. There is a human intervention is required. That is collaborative autonomous robots, autonomous mobile robots, AI vision system, digital twins. Okay, which will give you a real picture of both. It gives you both real life as well as the digital aspects on different products, and modular production units. So these are the some of the changes which is happening in manufacturing automation. So some example is Tesla. They have an AI-driven production cells. Okay, then Siemens. Okay, they are also optimizing their automation. So Amazon. You recently have seen the news. Amazon laid off some around 14,000 people because they extensively invest on automation. So these are some of the innovations in Indian manufacturing also. So in short, a lot of impact because of implementation of these technologies. Some of the measurable business results is faster customization, reduced downtime, quality improvement, and efficiency gains. So going forward, China earlier had an advantage of large infrastructure with the great government policies. Nowadays, because of AI and data-driven intelligence, now it is talks about adaptability, how fast you can adapt to the different situation, how fast you can make changes in the product life cycle. So that makes the competitive edge for any countries. So with that, I will just come to the conclusion. Maybe we will open for any questions. So in short, what I want to summarize the entire presentation, I started with the business model, which is prominent in electronics manufacturing. I was focusing on OEM and ODM, what is the advantage and disadvantage for both models. And I was also talking about what are the different kinds of innovations happening in the manufacturing, specifically in the electronics manufacturing. Third aspect, I was focusing on rapid prototyping, how rapid prototyping can trigger innovation at a faster pace. And the last one, I was focusing on the static automation to hyper flexible automation. That is the future of the manufacturing. So I just stop with this, and if you have any questions, can you please put on chat, or you can unmute your mic also. So any questions, any thoughts?
Participants, please use the chat, or You can unmute and talk.
Hello, sir. Am I audible? This is
Yeah,
Dr.
ma'am.
Asha
Yeah,
Vijay.
yeah.
Actually, the thing is that, like, sir, for example, the earlier things like the maybe a tailoring unit or the sewing machine, basically.
Yeah.
Like earlier, it was of different types. Now it is standardized.
Yeah.
Now, like every machine can use all the products that are there, the spare parts and all. And my question is that when this manufacturing is enhancing and the companies are having this multiple platform thing kind of, when they go for standardization, will that become a single kind of thing? I mean, that will be fit for every company or something like that. Will that happen, sir?
Yeah. So, one of the biggest challenge for most of these manufacturing companies is the cost optimization part. So that is where these sharing platforms will be really helpful. Now, this will be mostly on the consumer electronics side, but when it comes to the niche products, for example, aerospace and defense, okay, there will not be any sharing of the platforms. Okay. There is a lot of importance on the secrecy of the technology, lot of importance on the quality. Okay. That makes a lot of matters. Okay. And, if you talk about current electronics products, there is no much of differentiation, right? You see an LG or I don't see much differentiation in most of these electronics products. You may be knowing that there is a model called Vivo, Oppo, then OnePlus. Okay, and all these products are manufactured under one manufactured by one company. It's called B. I think I forgot the name of the company. It's called B2B or B2K or something. Okay. So just they try to change the white labeling. Okay. So only the white label is being changed and small changes in the features are there. So platform sharing is one of the common practices where you can we can see across even in the automobiles also, right? For example, Toyota and Suzuki, they try to share few platforms and they try to leverage on each other's strengths also. For example, Toyota does not have any entry level cars and they want to leverage on Suzuki's strengths to enter into that particular market. So a lot of things are there, but not on a very niche and high-end electronics. Yeah, Dr. Shan, thanks. BBK
Yes,
Electronics.
sir. Thank you.
Thank you. In manufacturing innovation, shall I say, finding the solution to the existing problem and innovation and patent, shall I find? Yeah, so innovation is we can talk about how you leverage on the technology to apply for solving an existing problem. So typically, ideally, if you want to protect your ideas or protect your invention, okay, it needs to be patented. So once your products become patented, you can get a lot of leverage on that particular technology, right? So that is what happens with OEM. So all this design and everything lies with the hands of Apple, and they don't want to give to others. So they purely focus on OEM models.
Participants, any more queries?
Yeah, if there are no questions, I think we will close it. In case if you want to reach out to me, okay, you can reach out to me. This is my email address as well as LinkedIn ID. Thank you very much.
Thank you. Thank you so much, sir. It was an insightful and enriching session. So we sincerely appreciate your time and contribution, sir. Thank you so much, sir.
Thank you. Thank you, all the participants.
Thank you, sir.
Our next session will be handled by Mr. Abhilash Savidan. I request Dr. Lishan to introduce him.
Thank you, ma'am. Good evening, all. It's a privilege to introduce our resource person for this session, Mr. Abhilash Savidan, Team Lead, FCEV Hydrogen Systems, Reliance Industries Limited, Bangalore. Mr. Abhilash Savidan is a seasoned automotive engineering professional with over 2 decades of expertise in advanced propulsion systems and sustainable mobility solutions. His career spans extensive work in product development, system integration, and safety engineering, contributing to several major OEM and research led programs in the areas of fuel systems and powertrain technologies. He currently serves as head hydrogen systems at Reliance Industries Limited under the Mobility Group, a position he has held for the past 4 years. In this capacity, he leads initiatives in hydrogen based mobility solutions, driving innovation and technological advancement in clean energy transportation. Prior to joining Reliance, Mr. Abhilash worked for 9 years at Tata Motors Engineering Research Center, where he served as head of fuel systems in the passenger car business unit. He also spent 7 years with Maruti Suzuki India Limited in the engineering research, design, and development division, contributing to several critical automotive engineering projects. A strong advocate of sustainable automotive technologies, he holds 5 patents in fuel systems and related emerging technology domains. With a deep commitment to technical education and industry academia collaboration, Mr. Abhilash actively engages with institutions and professionals to bridge practical engineering with rapidly evolving landscape of modern mobility. I extend a warm welcome to our esteemed guest and invite you to share your expertise and insight on smart manufacturing in the automotive industry. Welcome, sir.
Thank you, Dr. Lishan, for that extensive introduction. Can I start?
Yeah, sure, sir.
Okay, I am. So that is my screen visible?
Yes, sir, it's visible.
Okay, even though I am accustomed to giving technical talks at seminars and conferences, which are mostly related to my area of expertise or domain, automotive engineering, and I have done that even at engineering colleges. But this is the first time I am giving a talk in a management school. Okay, so I was wondering how easy it would be for me to explain engineering to management students. So I have tried to make the presentation in such a way that management students can also understand understand a little bit of engineering. So I hope it will work for everybody.
Yes.
So I'll start with why smart manufacturing before going into what is smart manufacturing. This, I think, is something which the management students will be interested in, as to why smart manufacturing is relevant to us. So the development time of a traditional passenger, I come from a passenger car background. I mean, most of my career I have been working on passenger cars. So I'll be talking from a passenger car perspective, and I think that will be easy for everybody to understand, because all of us, are connected to passenger car, own passenger car, traveling passenger car. So I'll be talking from a passenger car perspective. So development time of a traditional passenger car OEM for a new platform is about 45 to 60 months. Okay, that means that is the development time from conceiving the project to putting the vehicle on the road. This I am talking about a new platform. So a platform is like based on a platform, there can be multiple models. Okay, when you design a platform, you design it for a longer period, and you carve out different models from a platform. So this is the development time. Okay, 45 to 60 months. So that's about 5 years. Can be as long as 5 years. So here is some history. The Ford Model T is the first mass-produced passenger car automobile. When it was introduced, Henry Ford said that you can get the car in any color as long as it is black. Okay, why he said that? Because black was the cheapest paint available back then, and its drying time was much faster than other colors. So going for only one color helped him streamline the assembly line production process and the time. Okay, so it was also easy to control the costs involved. This was the condition back in in the time when Ford introduced his Model T. What's happening now? Now Porsche has something called a paint to sample thing for the customers, where the customer can choose any color he or she wants. Okay, that is where we are today. And Rolls-Royce has a personalization plan where it allows customers to choose from 44,000 colors. This is where we are today. Okay, and you have understood, right, the advantages of going for one color, and then you can understand the complexities of involved in going for 44,000 colors or any color you want. And it's not just the colors. Now when you go to buy a car, you can choose the wheels, the side, the rear view mirrors, the wheel caps, the colors. You can have whatever color you want. You
Sir,
can have
excuse me, sir.
Yeah.
Sir, the presentation is not in presentation mode actually. I mean, the PPT is not in presentation mode and it's not moving. Yeah.
Okay, something is maybe you are getting the presenter's view. Is it?
So we are able to see the PPT, but not in the presentation mode.
Okay.
Sir,
So
you
the
have
slides.
not shared that presenter's view. That is why.
Oh, maybe I shared the presenter's view, you are saying. How do I change that? About Zoom, I'm not really.
Sir, if you do right click, I think one down you will have that bar. From there you can select it. Select the things.
No, sir, on top it is there, no?
On top?
On top, after save
Where?
button, third one.
Where?
After save button, third one.
Save button.
Save, not that one, sir. Go back.
Yeah.
There,
Yeah.
third one.
Okay.
That one. Click on that.
Is it? What is it like now? Can you see the second slide?
No, we are not able to see.
The screen is like blank or what? Or
No, we can see.
No, we are seeing some images.
Sir, once again, are you in the presenter view? Are you in the presenter view, sir?
Yes.
Sir, you can see that above one this thing is there. You can see that video or something like that. Show taskbar. Show taskbar display settings. So you click on that show taskbar.
Okay, what about now?
Sir, you click on that show taskbar. Below you will get the taskbar. In that you have to go to the Chrome. And in that you will get the meeting. In that you have to share the screen. That is how it goes.
Taskbar, then I go to Chrome.
Chrome. In that you have to come to the this one. Meeting. Zoom meeting. Chrome or Zoom meeting, whichever it is, which you are opened in either in Chrome or in Zoom. You have to come there, and there you can open it.
Oh, man. I think I am lost. Let me try unsharing and sharing again.
Or you share your entire screen, sir. That's better.
Yeah, maybe that's what I should do.
Or else you can send me the PPT, I will share. I'll move the
It's,
slides. That also is
it's
possible.
that's a heavy file. It's a heavy file. Okay, let me try again. I have a lot of images.
Okay, sir.
Because, is it any better?
No, same,
Okay, I'll
sir.
go for your full screen once again. If not, we'll go in the.
Now, okay, sir.
Now
Okay.
it's fine, sir.
Now, okay. Yeah, now
Yeah. So this is where I was. The slides are changing now, right?
yes,
Yes,
yes.
yes, sir.
45 to
fine.
60
Yeah.
months. Yeah.
Fine. Yeah, I was saying that putting one platform right from drawing board onto the roads can take up to 45 to 60 months. Okay. And yeah, I was talking about Ford and why Ford was offering only one color back in when they introduced the Ford Model T, the first mass manufactured car. And right now we are offering any color you want. Porsche is offering any color you want, and Rolls-Royce is offering 44,000 colors. Yeah. And like I was saying, we have a huge scope for customization for the car buyer. We can have any shape of wheels today, any kind of mirror, different options for colors for the wheels, different options for leather. For the upholstery, you can have leather in different colors or non-leather, and you can have different kinds of seats. So these are the kind of options that are being offered today, which started with only one color back when Ford introduced their Model T, the first mass manufactured car. All right. And on top of that, one car can have as much as 30,000 parts. Okay. One single car can have as much as 30,000 parts. Now imagine the number of complexities and number of parts and variations and variants involved when you're offering the customers these kind of choices. On top of that, people wants more features. Here I have put some customer expectations from some of the major countries around the world. This is a study by Deloitte. So as you can see here, a country like India, we want features. The customers are asking for even more features. Okay, Indian customers are demanding more features than German customers or say Japanese customers when it comes to features. And the customer is also ready to pay for the extra services, right? So if you look at India, see automatic detection on vehicles and pedestrians, for those kind of features, Indian customer is ready to pay additional amount for that. So that is where the customer is. Customer is demanding different variations, different choices, and personalization. And customers are willing to pay a premium for what aligns with their desired lifestyle. These days, people match their handbags with the color of the car and all that, or their nail paint with the color of the car, or the color of the shoes with the color of the car. That's what the modern customer wants. So this is where we are today, from like in the early 70s to mid 70s, where we had to book and wait for years for the car to arrive. I'm saying years, not year. So that was a waiting period back in the 70s. And here is a different story. Okay, if you look at the iPhone story, which started here, I have the iPhone various releases starting from 2007 till today. So every year they will come up with a new iPhone. Every single year they will come up with a new iPhone, and that too around the same period. And people expect a new iPhone around the same period every year. That's where we are today. So that has made the automotive designers and those in the automotive industries, not the engineers, the entire managers and management and the finance experts and guys like you, smart people like you, who does the product development, product consumption and all that, study the market. So when earlier it was like you make one model, you decide some contribution or margin on that model, and you sell number of vehicles and you get your return of investment, and then you start making a profit. But now it's not like that. Now you make a platform which can last for, I don't know, maybe 10 years, 15 years. You come up with different variants, different features, and by that, along that journey, there will be new regulations, new safety norms coming in. You have to integrate all that onto the newer models or face changes, facelifts, which you plan to have. And in such conditions, they are controlling the R&D costs, capital expenditures, variant complexity and cost and all that. It becomes more complex, and you have to consider the life cycle of the platform itself. Okay, so that's how you manage the finances today. That is where we are now. So the focus on cost and revenue optimization is done for the entire life cycle of the platform. So we have come to, you can get it in any color as long as it is black. To your wish is my command. So that is where we are. So this is where we need smart manufacturing. Okay, with the traditional manufacturing methods and manufacturing methodologies that were followed earlier, we cannot handle these kind of variations. We cannot handle this kind of complexities. And you cannot keep the kind of inventory you used to keep, like where there was only one variant and there was no flexibility and there was no complexity. So this is where smart manufacturing becomes relevant. Okay, I have put some pictures from the manufacturing line from the passenger car industry. The reason I have put the pictures is I understand there will be people from different streams in the audience, and there will be also students from the management stream. So this is for you to imagine. I want you to imagine a passenger car manufacturing shop. Okay, so that's how I am going to take the story forward. So what you see on the right is a weld shop. Okay, weld shop. After the weld shop, the weld body is being assembled. Okay, weld body means individual sheet metal parts are pressed and welded in a weld shop. Okay, that is the first phase. What comes into the weld shop are sheets of steel. Okay, sheets of steel rolled into. You must have seen in some highways big trucks carrying rolls of steel in it. So rolls of steel sheets is the material which is coming into a weld shop. Okay, so they are then cut, sheared, stamped, and made into shapes, and then welded. And you again assemble all the welded parts, again weld them together and make something called a weld body. So what you see on the right side is a weld body. It's just a sheets of metal, bent, formed, welded, and bolted. Okay. Yeah, this here. Okay, these are the inputs. Okay, I'm giving you these inputs so that I can take my story forward. So you have to understand the various stakeholders in the car business. Okay, so at one side we have the car buyer. This is us, the car customers. Then we have the car dealership. This is where we go when we have to buy a car. And after that, there's a marketing and sales team of the OEM, the vehicle manufacturer. So the vehicle manufacturer and the car dealership will be talking to each other. So the projections from the raw data from the market as to what the demand is going to be like, how many cars are required, which month, which variants, when, and the trends and everything. This will all go from the car dealership to the marketing and sales team of the OEM. Okay, and then we have the supply chain management team of the OEM, the car manufacturer, who will be procuring the materials from these hundreds and thousands of suppliers and vendors within the country and from abroad for the imported parts. Okay, so I am, like I said, I am considering a passenger car scenario. Okay, to be specific, I have tried to bring in the Maruti scenario, because I have been associated with Maruti for about 7 years, and it's the largest manufacturer of vehicles probably in the world when it comes to sheer numbers. So yeah, and there will be something called a KD warehouse. KD means knocked down the imported parts, because they will be having huge logistic times involved, lead times involved. So imported parts will be imported and kept in a warehouse, okay, for longer duration. Usually, if you are all the parts will be traveling through sea, and usually 45 to 60 days is considered as lead time. So you have a warehouse for keeping your imported parts. Okay, and here we are considering just in time in a plant where we have just in time is implemented. Just in time means you don't keep inventory. If you take the case of Maruti doesn't even keep inventory for 1 day. Okay, back when I left Maruti in 2013. So back in 2013, the inventory of Maruti was 0.8 days. That means trucks will come to the plant twice a day. Okay, so for the inventory was for less than 1 day. So the trucks will come twice a day to take care of the production requirement. And there is something called just in sequence. That means the part will go to the line just when the operator wants it. And what you see here, the supermarket, this is at this is where you keep some of the parts which is next to the line, next to the assembly line. What you see behind is the assembly line. These parts are kept as adjacent to the assembly line, not for the operator to take, but for the other personnel to take from here and take it to the assembly line. Okay, so assembly line is where the car is manufactured, the car is assembled rather. Okay, and this is a pictorial representation of an assembly line. What you see here, manufacturing, what I have shown. I hope you can see my laser pointer, right? Yeah, and okay, I am audible, right? I don't.
Yes, sir, you're audible.
Yeah. Okay, these are the various tools or platforms or whatever you can call, which are involved in the manufacturing of automobiles. We have men and machines. Man and machines. Man is a neutral gender, by the way. I mean, I'm considering man as a neutral gender here. And we have PLC, programmable logic control tool to connect. We have manufacturing execution system. And we have ERP or SAP, some kind of tool which to take care of the inventory and all that. Okay, so these are the various tools involved in the manufacturing system. And we have a department, very important department, it's called production planning and control. So these people are this team. They are the ones actually controlling the entire manufacturing line and controlling the inventory also. Okay, they give, they plan the activities, give plans to supply chain team, marketing team, to the plant, the warehouse, assembly line, everyone. Okay, so they are the planning team for PPC, production planning and control. Okay, here I have put some more pictures for you to understand some of the important phases in the manufacturing of the vehicle. This is required for understanding the rest of the story. So yeah, here is on the left top end, you can see a weld shop. This is where all that welding happens. What I showed earlier was the weld body. That was the body after completion of the welding. Okay, this is the weld shop. This is where all the welding take place. Usually, the weld shop is heavily automated because you need very high speeds, and you will see a lot of robots on a weld line. Okay, and this what you see in the middle is the paint shop. Okay, paint shop is also heavily automated. In fact, most of the paint shops in India, there is no human intervention. The painting is done completely by the robots. And yeah, this here on the right top, what you see is the assembly line. So assembly line, this actually is called the trim line. Okay, this is the weld. Okay, after painting, the weld body is painted, and after painting it comes to the assembly shop. Okay, this is the place where you put on the initial parts. Okay, the wiring harnesses, whatever the wiring harnesses, the seats, the mirrors, no, the inside mirror and things like that. Okay, this is the trim line of the assembly line. And this is the engine docking line. This is where you dock the engine. What you see here is the engine onto the vehicle. Okay, so engine is brought in, engine and axle, usually engine and axle and suspension as an assembly is brought in, and it is docked onto the vehicle. And what you see here is called an overhead carrier. This yellow thing is called an overhead carrier. Because these overhead carriers, okay, there is something called a flexible line. Okay, so for example, Maruti has a flexible line, and means in one line they will be making different models, different variants depending upon the market requirements. So these overhead carriers or OHCs are designed in such a way that it can take or it can carry different variants and different models and sometimes different platforms also. Okay, so there are times when the vehicle in which is being manufactured will be on the ground on the conveyor, and sometimes it will be hanging on an overhead carrier, and then parts will be assembled onto the vehicle from below, like for example fuel lines and things like that. Okay, yeah, so I think now at least you must have gotten some idea about what the automotive assembly line looks like. So yeah, in these pictures you must have seen that there are no doors. Okay, there are no doors here. After the weld body is made, after the painting is done, the door is taken away. Okay, that's because to provide access to for the fitment of everything, seats and things like that. So door comes later. So if you look at the engine shop, again it's the same story. But engine, the number of variations are limited. Usually in one line, what I have at least seen in my career is that usually in one line you make one engine. Okay, there will be a family of engine. In one line, you will be making usually one engine, or it will be one family of engines. Okay, for example, if you talk about Maruti, I can say they have this K series engines, K12, K10. So that for that there will be an engine shop. And for different series, for a different F series, so G series, which is used in the old Alto 800. So they have a different family of engines. The Eco has a different family of engine. GC. So therefore, usually for based on family, the engine shop will be different. So from the engine shop, what you see in the middle is called a automatic guided vehicle. Okay, so this automatic guided vehicles are used for carrying parts from the engine shop, like engines from the engine shop or from other assemblies from the sequence shop. I'll tell you what the sequence shop is. So here you'll see only doors are coming. Okay, here only doors are coming. So these doors will be having different colors, and it has to match with the vehicle with the appropriate color later on in the assembly line. That's why doors are coming in a different line. Okay, now let us look at the traditional way of manufacturing, the non-smart way of manufacturing. You only have one car, you only have one model. Yeah, the car has come to a station. Station means the place, okay, along the assembly line where the vehicle will be moving in one direction. There will be people standing at different locations, okay, and this will be moving. So one person will be assembling a set of parts, and the vehicle will move forward. The next person will assemble set of parts and move forward. That's what the line looks like. So we have an operator here. So this car is coming to his station. So he has some bins by his side. So he will be taking parts from his bins and fitting onto the car. The car will be moving in this direction, in whichever direction the conveyor moves. Again, after his work is done, he will come to station 1. Okay, he will come back here. So let us say the conveyor is moving from left to right. So he'll be taking parts from bins 1, 2, 3, 4, and 5 and fitting onto this vehicle. Then he'll go back to bin number 1. By that time, the next car will come. Okay. So first, when the car is coming, there will be a tag attached to the car. So looking at the car, he can understand which vehicle. There may be 1 or 2 variants, for example. So whatever 1 or 2 or 3 variants, based on that, he will check. And after reading that, he will take the required parts from these bins, and then he goes back to station 1. Okay. I hope you are able to Imagine the line. Okay, now let's talk about the modern automobile plants, where we have very high model mix and we have so many different variants. Yeah, we as customers, as car buyers also itself, we get confused when we are offered so many variants, right? When we are offered like 5 to 6 variants today, they are offering a lot of variants and they can try to confuse us. I mean, the numbers are so big. So imagine the kind of complexity and variations that the manufacturers has to handle. So yeah, so that's what I'm trying to say here when I say high model mix and variant heavy options. And we have sequenced parts. Okay, what sequenced parts means is like, okay, I will give the example of instrument panel. Okay, what the instrument panel is what you see in front of you when you sit on the driver seat at the co-passenger seat, right from the left to the right, the entire thing. Okay, the whole thing is called an instrument panel. So if you talk about an instrument panel, that includes the steering, the cluster, where you can see where you have the speedometers and odometers and all that, displays and all that. Then you have your digital display, where you play your music, your navigation and all that. Then you have your AC vents, your airbags, and then you have different colors, right? Wooden veneers, leather red color, sporty mode and all that. So yeah, so this is the kind of variations the instrument panel has. And now imagine, okay, I'll come to that later. So when a particular car is coming to the station, the operator needs the right instrument panel in front of him so that he can take it and he can fit it on to the right car, right? So that, because we have different variants. So these are called sequenced parts. Okay, I'll explain later what sequencing really means. Okay, rapid takt time changes. Okay, this I'll explain later because I'll have to tell you what takt time is. And very tight inventory windows. Like I said, if you are going for just-in-time inventory with keeping almost zero inventory because you don't want to spend money on dead inventories. Again, that is another complication. So these are some of the challenges modern automobile plants have. So there is something called e-Nagare, electronic flow control system. It's a smart manufacturing solution. This is followed in Maruti Suzuki. And this is what I'm going to explain today. Okay. Yeah. So this e-Nagare electronic flow control system. Nagare is actually a Japanese word. It means flow, by the way. This smart manufacturing solution is designed for high variety, high frequency parts and line side sequencing. Again, I'll explain sequencing in detail in the coming slides. Just in time and just in sequence. Just in sequence means, like I said, you have a car with say X variant of the instrument panel, and that instrument panel should be in front of the operator when the car comes. Then when the next car comes, the associated instrument panel of that particular variant should be in front of the operator. Real-time demand communication between assembly line and supermarket and warehouse. Okay, this communication has to be there. Only if that communication is there properly, the channels are there, then only the operator will have the right part in front of him when the associated vehicles arrive in front of him. Okay, these are the requirements. Okay, and this smart manufacturing system, it is usually digital. It is digital. It has to be real time. It must be flow based, and many material replenishment must happen on the fly. Okay, that system has to be there. So in short, it is dynamic, continuous, and material calling is real time. Okay, now I'll tell you what is takt time. It's important for you to understand what is takt time. Takt time is the customer demand by available production time. Customer demands means how many cars do I have to manufacture today in one shift? Okay, in one shift, and that divided by the available production times. So for one shift, if you assume we have 480 minutes and the customer is demanding 240 units, then the takt time is 480 divided by 240. That means 2 minutes. That means you have to make one car every 2 minutes. Okay. So that is takt time. That's the definition of takt time. By the way, when I left Maruti in 2013, the takt time in Maruti was 27 seconds. Okay, that means every 27 seconds, the car used to roll out. Okay, but after I left, they made more plans. I don't know what is the takt time today. It must be much lesser. Okay, so here we have a picture of an instrument panel. Okay, so now you know what the instrument panel comprises of. This is some random picture I found on the internet because I couldn't find the right picture I wanted, and because of confidentiality issues, I am not able to share pictures of my instrument panel also. So this is the instrument panel. So the rest of the story I will be explaining, taking instrument panel as an example. Okay, the entire story, because I felt this would be the right example, because we all have seen an instrument panel right in front of us. It's not sitting, hiding away somewhere like the suspension or your fuel tank or anything. Okay, now let's take an example. In this example, we are assuming 55 seconds, and we are talking about instrument panel only now. Okay, the assembly of the instrument panel. So we have a takt time of 55 seconds, and we have, let us say, 40 to 70 variants. Okay, combinations and permutations based on color. HVAC. HVAC means the air conditioning, heating, ventilation, air conditioning. There can be normal climate control, automatic climate control, where you can set the temperature. Then you will have different trims, chrome, without chrome, and all that, different colors. And there will be variants with head-up display, and based on all that the brackets which will be used for fitting these child parts onto this instrument panel will be different. There will be airbags, there may not be airbags, and trim level means this the trim, the fit and the finish of the panel can be different for different variants. So these are all the variants. Sequencing center located 150 meters away. Okay, sequencing center is where the assembly of the instrument panel, the parts required for the assembly of the instrument panel will be kept. Okay, assembly of the instrument panel. So yeah, so these are the parts. These are some of the parts that we saw. So all that parts will be kept in a sequencing center, which is located 150 meters away from the assembly line, which I showed you earlier. Okay, that is the assumption. Delivery mode is AGV train. AGV I have showed in my earlier slide. It is the automatic guided vehicle. So the automatic guided vehicle will be taking the parts required for making this assembly from the sequencing center, which is located 150 meters away. Okay, now how is all this controlled? We have the manufacturing execution system, the Nagare, the SAP or ERP, and the warehouse management system. So these are some of the smart manufacturing tools which will be employed for carrying out the control of this activity. Okay, now let us assume we have to make 4 cars on the line, and the variants are VX, EX, VX, and CX, and these are the color options. Okay, this is the sequence of these are the cars that we are going to manufacture today. Just assume. Okay, and these are the options for the instrument panel for those 4 cars. The first thing the manufacturing execution system does is it will build a vehicle build sequence, and it will generate the VIN. VIN is the vehicle identification number and variant information. And at takt 0 seconds, manufacturing execution system will broadcast. This is going to be the car sequence for today. Car 1, car 2, car 3, car 4, the VIN number, and VIN number will be able to tell what variant it is. Okay, this is digitally broadcasted by the MES to all the systems that we mentioned earlier. So the e-Nagare system, when it gets the VIN sequence, it will convert it into part requirements. So it will make the part requirements. When this vehicle is coming, these parts are these particular bill of materials. Actually, okay, the bill of material for these variants will be made by the Nagare, and for each VIN number, e-Nagare will check the instrument panel BOM bill of materials and map it to the correct variant. Okay, so we'll have to have different variants of instrument panel for these 4 cars, which we saw in the here. Car number 1, 2, and 3, I have written VX, EX, and all that. So the Nagare will map the instrument panel BOM to the correct variant. So these are the instrument panel BOMs variants. Okay. So the first variant for car 1 is going to need variant A9B. That is the variant number of the instrument panel, where you will have black color, you will have head-up display, and you will have a premium, maybe Boss audio or something. And the car 2 will need a different variant, C4D, which has a beige in color and standard. So the e-Nagare will make these variants, and the BOM will be ready as per this variant requirement for the corresponding cars that will be coming on the line today. Okay. So, okay, I am trying to make you guys imagine what it is like. It's like, this e-Nagare system is making a box of assorted chocolates, and some of the chocolates will be different. So it will take these parts and put into boxes of chocolates. Okay, so this is one. Let us say what we see on the left is a variant of A9B, and these are the parts which will be appearing in that box. So output of e-Nagare will give you the sequence now. This A9B, C4D, this is sequence for making the chocolate boxes I'm talking about for these cars 1, 2, 3, and 4. Okay. Yeah. Now here I am giving some examples, but these are parts which the non-engineers or non-car enthusiasts may not understand. But here, this person, he is making these chocolate boxes. Okay. Okay. And this will be later on sent to the operator at the station. Okay. Here I have a different part, but you can see different seats of different colors sitting here. Okay. These seats are sitting here based on the arrival of different car variants. Okay. So in case you don't understand or need clarity, tell me, okay? Because I think I don't know how well I am able to communicate everything, and how to what extent you guys are able to visualize all this. Okay. So now, after the output is gone, the sequencing center is the place where I said this person is making all these chocolate boxes. So sequencing center will receive the sequence instructions. So the operator over there, he has the sequence instruction. So he will have a handheld device or something which will communicate the sequence instruction to him, and he will go and make those chocolate boxes. So there is something called a pick to light racks. So let us assume each of those different variants of chocolates are sitting in these boxes, and he will pick the relevant chocolate from the relevant box for that particular variant. Okay. So how does he know which to pick? So this rack is again a smart rack. The light will glow. Okay. So what he has to do is pick up the part from the bin where the light is glowing. Okay. Okay. Based on the IP variant code, we have variant codes, right? That A9B, C40, these are the IP variant. IP means instrument panel. Okay, and then we know the exact time that is needed at the line. So this, let us say the instrument panel variant 1 will be required, say 1 minute from now. So that information is available. That's called the time to delivery. Okay, and then we know the AGV departure. AGV is that automated guided vehicle which is roaming around the shop floor, picking up parts, delivering parts. It is completely driverless. It's completely automatic. Okay. So the AGV departure window should be known to us. So that means the AGV has to come to the sequencing center to pick up once the chocolate boxes are ready, and then AGV has to take to the line. And then these are loaded on the delivery racks, okay, as per the vehicle drop sequence. Okay, again, that means we have now different chocolate boxes put on a bigger rack in the sequence of the vehicle delivery drop sequence. Drop means the weld, after the weld body, I told you the weld body goes for painting, and after the painting, doors are taken off, and then what we have is the paint body. We call it the paint body, okay. So yeah, so paint body, that the terminology which is used in the automotive industry is called dropping. The body will be dropped, okay. Usually the body will be traveling from the paint shop through an overhead conveyor to the assembly line, where it will drop from the top, okay. After that, the operator will start working. So that is a drop. So that is the drop sequence we are talking about here. Okay, so when our chocolate boxes are kept in a rack as per the vehicle drop sequence, the e-Nagara sends a trigger to the AGV control system, okay, and the WMS, that's the warehouse management system. So the signal goes to the AGV, and signal goes to the line side receiving team. Line side receiving team are the people who will take the parts from the AGV and keep it by the side of the line for the operator to assemble. So the AGV will come automatically, and it will take, somebody will put the chocolate box rack onto the AGV. In some places, even those activities are automated, okay. Some crane or robot will take it up and put it onto the AGV. Yeah, now AGV goes to the line side supermarket. Supermarket I have showed you in one of the slides. So this is sequencing station where all these chocolate boxes are packed. That is the sequencing. That's 150 meters away is what we assumed. Okay, so from there it goes to the supermarket, which is by the line, assembly line. Then this is how you calculate the dispatch time. Dispatch time will be line consumption time minus travel time minus buffer time. There will be some buffer. And these boxes are tracked by RFID or GPS tracking, and route optimization is also done. Okay, because the AGV sometimes will be carrying more than one boxes of. There may be different boxes of different things. Okay, boxes of chocolates, boxes of cakes intended for something, some different assembly. So at that, these will have to be delivered at different stations, different locations. So the route optimization is also done by this system. And then the line side supermarket receives the rack. So at the line side supermarket, what happens? The operator verifies the sequence is correct or not, because he also has the sequence with him, so that he checks with his handheld scanner. And the manufacturing execution system confirms the positioning. Okay, there are positions for keeping the racks, so that is again confirmed. So if there is a wrong sequence, an alarm is triggered. Now the operator starts the installation of the instrument panel exact build order. So when car 1 is arriving, his screen will tell him that you have to pick up IP variant A9B. So he picks up the IP from rack position 1, okay, for the first car. So now the operator, because the number of variants are high, operator will be shown instructions as to, these are again, these pictures I could not get the right pictures for the instrument panel. So here I am just giving you some examples. Here on the top, that's an instruction for the build of the engines. Okay, the system is same for engines or vehicle or whatever. So the operator will be seeing the assembly instructions on a screen by the side of the line. And nowadays they have started implementing AR and VR also, augmented with reality and virtual reality, where you get more information, like more clearer instructions as to what to fit where, which tool to use, and all that. Okay, so that is a representation of the main image below. Yeah, so after installation, the operator scans the IP serial. The manufacturing execution system post consumption, that means that is consumed, that will be recorded. Okay, So that will be recorded by the Nagare again, which again will be pushed back later on into SAP and the inventory and all that. So this process will continue for car 2, car 3, and car 4. So each scan drives the next cycle of the Inagari. Okay, after one scan, next cycle will start, because again all that sequencing and everything has to happen for the rest of the vehicles, and this will continue. Yeah. Okay, so now what is SAP or ERP, enterprise resource planning, whatever is implemented in the OEM, what does it do? So it handles the inventory adjustment. So SAP knows how much consumption has happened, what is sequence control cycle management. Based on that, it also knows what is the upcoming plans. So based on this, it may release POs or initiate release PO for the next lot for required for the next shift or the day, next day or whatever. And scheduling will be given to the supplier. Supplier will know, okay, what is the plan going to be left for like next week or next month, all that. Warehouse management, based on that, warehouse management task management system task will be created by SAP. Backflush posting. Backflush posting is the updation of inventory, okay, based on the consumption. And variant configurations, material numbers, and bill of materials. So this is what the SAP does in the background. Okay. So now we have all these problems sorted, okay, which we were having earlier when Henry Ford was facing when he was supposed to make cars with one variant, one color. So now we can have car by car variant selection. We are doing real-time sequencing. We are handling 40 plus variants, and we have just-in-time delivery also for the operator, and zero bin system. We are not keeping like hundreds of different parts by the operator, for making the different variants and all that. So there are no bins. Okay. So now this was the this is what we have now in India, and now because we have AI and machine learning and cognitive manufacturing, all that things are changing. So I'm talking about what is going to happen beyond Industry 4.0. So here systems Industry 4.0 mostly, you must have heard, it's mostly about collection of data, putting up a lot of sensors in all the lines and collecting all that data, making sense of all that data and all that. Okay. So here, this is beyond just collecting data. This is about understanding the data, learning and acting. So that's what cognitive manufacturing is about. It is the newer trend, I would say. So here the factory becomes self-learning and self-correcting. So here we have AI, Internet of Things, contextual learning, because it will learn based on the contexts that are presented to it. And autonomous decision making. Decision making is also done. Okay, no human intervention. Again, let's go back to the example of the instrument panel. Okay, let us assume a case during instrument panel assembly, operator is frequently triggering the unknown for the misaligned HVAC duct bracket. Okay, this is the scenario that we are trying to imagine. Okay, I'll explain what it is. So we have this instrument panel assembly. We saw it has got so many child parts. Okay, and HVAC is the heating, ventilation, air conditioning duct. So there is a duct. What you see is that air vents. You must have seen air vents in the car, right? So usually there are two in front and two by the sides. So these ducts are these vents are connected to something called a HVAC duct. Okay, there is a duct which is inside the instrument panel, which is sending that cool air to the passengers. Okay, so that duct is fitted onto the instrument panel, and there is something called an I-beam, I-pillar, in fact, behind the instrument panel. So it's onto the okay. Names can vary from OEM to OEM. Okay, So I pillar is a long I-shaped or a round bar which is from the left hand side of the vehicle to the right hand side of the vehicle, on which this instrument panel and the air conditioning system, all the other accessories along with the wiring harness, everything is bolted onto. Okay, so this HVAC duct that we are talking about will be sitting behind the air vents inside this instrument panel, and it will be, in most of the cases, it will be fixed to this I pillar. Okay, so through brackets, of course, right? So the case that we are assuming here is that during instrument panel assembly, operators frequently trigger unknown for misaligned HVAC duct bracket. We have a problem with the duct bracket. Okay, the duct which needs to be mounted onto the I pillar, it has got a bracket. The bracket is not getting properly aligned, and because of that, the operators frequently trigger unknown. Unknown is something called it's a call for help. Okay, in the assembly line, usually operator will have the string top above his head. In some modern days, there are, I think, switches also. So he will pull that string. Okay, that is called unknown. It's a French word. So when this is pulled, there will be these lights by the end of the line, which will be visible to the line supervisors. Okay, so when this fellow he pulls this usually when there are no problems, green light will be glowing. When he pulls it, the yellow light will glow. Okay, and usually the alarm will start buzzing, and that means he has a problem. Okay, usually what happens is the supervisor will come running and they will investigate and they will fix the problem. Okay, the supervisors are usually people who have worked in the line for very long periods, and they are extremely experienced, and they are usually equipped to handle any kind of situations normally. Okay, so they will come running and they will fix it. So yeah, the supervisor will know where this problem is happening also. Usually the station number will also be displayed, okay, along with this station. Usually station is the place where the operators are standing and where is doing the assembly. There will be different stations. Yeah. So in cognitive manufacturing system, what happens is the AI will detect a pattern in the Andon cards. Okay, the pattern means this particular incident may be happening only for certain variants. Okay, those kind of patterns is what we are talking about here. So over 3 weeks, for example, data shows IP station 5, that is the station where the IP is assembled onto the vehicle. It has raised 36 Andon signals. This is what data is saying. Okay, station 5, yeah, this is the display I was talking about here. So usually along with the light, the station number will also flash. So it gives a defect code. The same defect code is coming. The defect code says HVAC duct misalignment. And mostly this is happening 2 to 4 p.m. shift. And higher frequency when a particular operator is absent. Okay. And supplier of this particular lot correlates with the most errors. So this information or this pattern is detected by the AI. Okay. The humans don't know about this. I mean, for humans to understand this, they have to sit and analyze and all that. So now the AI knows. And the cognitive system recognizes this pattern without being told. We are not telling the system to not do it. It's notices and recognizes and brings out this insights by itself. So now what does the AI do? The AI will inspect the process using vision system. Okay, there is something called vision system in manufacturing lines, usually in India for critical systems. Okay, again, like I'm saying, this I am trying to keep a single example all through my explanation for you guys to understand. So for critical parts where you require high accuracy levels, you put these cameras on the line. Okay, these are high definition industrial cameras which can see if, for example, the operator, did he forget to put on a bolt, or did he forget to put a washer or did he put a right washer, or did he forget to torque it or not, or let us say he has to torque 4 bolts and he forgot to torque 1 out of 4. All this can be seen and understood by this vision system, and appropriate action will be taken. For example, if the operator is putting the wrong washer in the system, it won't let the station move forward. For example, the fixture to close, and he won't be allowed to make the next move. Okay, next. So that intervention interlocking is done. So that is what these vision systems are about. So here we are assuming that this vision system is available in this IP assembly station. So we have cameras and machine learning. So what it says, it will measure the bracket. Okay, it will measure the dimensions of the bracket. By the way, this is the duct I was talking about. This is the duct I was talking about. Here there are 2 openings in the center, one on the left and one on the right. It's coming from the blower, which is blowing the cold air or hot air or whatever. Okay, and this is the bracket, which again, this is an imaginary bracket. Okay, this for you guys to understand. This is the bracket which holds this duct onto the what do you call it? The eye pillar I was talking about earlier. Okay, so this vision system will measure the dimensions of the bracket, and it has found out, or it can find out that the bracket is slightly out of tolerance. Okay, out of tolerance means some dimension is wrong. Maybe this hole has shifted by some distance, or the size is different or something. Okay, these are that part, meaning the part is not as per the design intent, not as per the drawing. So this is understood by the vision system, and variation increases as the shift progresses. So that means that is an indication of operator fatigue, right? Maybe the operator is sitting in some machining center, he's drilling this hole. After some time, he got fatigued and he's not putting the part onto the fixture properly, so that the hole is getting shifted or something. Okay, so this indicates variation. If the variation is changing as the shift is progressing, means so there is a problem of operator fatigue. Okay, and then misalignment is higher when robot picks parts from bin to specific task position. So this here we are assuming that this part is not taken by the individual; it is being picked up by the robot. Okay, so like I said, there will be different brackets for different duct variants, and let us say this bracket is sitting in bin 2, which is at a particular position. Okay, at a position with respect to the position of the robot. Okay, let us assume the robot is fixed with a flexible moving arm. So bin 2 is at a specific position with respect to the position of the robot. And yeah, so system correlates data on its own, and operator behavior, supplier loads, bin position. So based on all these, the system will correlate the data of its own. Okay, yeah, this is the robot I was talking about. This is just an example. Okay, so what does the system do? The system will execute or propose solutions. Reconfigures cobot pickup facility by 1.5 degree. Cobot here means a collaborative robot. Okay, that means I don't know if you guys have ever been to a manufacturing facility. So there will be some caged robots, and there will be some open robots. Okay, so these open robots are called collaborative robots, which will be working along with humans. Yeah, so this robot is helping the operator by picking up this part and giving it to him. Okay, probably because the part is heavy. So it will reconfigures the cobot pickup by angle by 1.5 degrees. Pickup angle is this. Okay, so the AI and cognitive system understood that there is a problem with the position of the bin, and the robot, the approach angle of the jaws of the robot is not right, and so what it does, it reconfigures the pickup angle. Okay, and update eNagar work instruction for additional fit check. He put instructions in eNagar requesting for additional checks of the bracket. Okay, bracket dimension. So reorder supply material quality checks for lot, this particular lot. Okay, so again it will send some information to the supplier is requesting full dimensional report or inspection report for this part, for that load. Suggest rotating operators every 90 minutes to reduce fatigue. So it is suggesting to, based on the the frequency and the when the defect parts are manifesting or coming up, okay, based on line. Based on that, the system will suggest rotating operators every 90 minutes to reduce fatigue of the operator, and predicts future defect probability for the next 24 hours. So based on these interventions or proposals, it will predict the future defect probability also. Okay. And also parallelly, it will trigger preventive maintenance on the pick and place end effector. End effector is this jaw. Okay, it is assuming that okay, something is wrong with the jaw, the end effector, which probably is deformed the part when it is picking up or something. So it is giving maintenance, preventive maintenance for the pickup end of the effector. So the E-Nagare automatically adjusts the line flow when misalignment probability spikes. Here, what it means is that the line speed, it will adjust a bit. Okay, so that means it slows down line speed when this particular operation is happening. Okay, at station 5. Station 5 is where our operator is assembling the instrument panel. So there, it will slow the takt time by 4 seconds, and then again later on it will get adjusted to adjust. So this also will be done by the Nagare, and increases micro buffer WIP. Okay, micro buffer WIP means usually for cases of emergency, some buffer parts will be kept at the station. Okay, for the operator. For example, this particular bracket, there may be some spare parts bin by the operator to take care of situations where take care of such situations. So what it does is, it will, maybe earlier there was one spare part, now they will be keeping more spare parts for emergency. That is the micro buffer WIP, work in progress. Resequences variant mixing to reduce peak loads. So to reduce the peak loads, it will adjust the variant mixing so that this troublesome variant will not come during peak loads, if that is possible. Again, and like we saw, it also noticed that there is operator to operator variation. So it will also send operators skill assignment recommendation. Maybe it will recommend to send the operator for reskilling or retraining or something. Okay. So yeah, and it does preemptive and then is that string I was talking about, which the operator pulls. This E-Nagare system will pull the and then by itself. Okay, instead of waiting for an operator to pull the and button or the and string. Yeah. Okay. So now the system has become self-balancing and self-optimizing, and system predicts likely okay. So the system will be able to predict defect likelihood, suggest an inspection or auto stop decision. Okay, this and when I am talking about and there were 3 lights, right? One was the yellow light. That's when the operator will come run. I mean, the supervisor will come running to help the operator, and then there is the red light when line will stop. The line situation will become like the line has to be stopped, which again in a company like Maruti, where you churn out one vehicle every 27 seconds, stopping a line is equivalent to committing a murder. Okay, that's something you cannot imagine. Yeah, so that should not happen. Yeah, on top of that, it will send a report to the supervisors in natural language. Okay, it will say like defect pattern detected, root causes, dimension saved, operator fatigue, and all that. So action applied also. Okay, action applied, action recommended, all that it will do, and the reduction defect probability also it will give. Yeah, this is cognitive manufacturing, and it's about understanding, learning, predicting, acting, and explaining. So everything it does, understands, learns, predicts, then action is taken by itself. recommendations are given, then it will explain what I have done. Yeah, so there is no human intervention. So that is it. That's it, I guess.
Yes, sir.
Yeah, I'm done. So I don't know how well I was able to explain, because asking you all to imagine the entire assembly line in your heads is not easy. That's why I used a lot of pictures. So I am
Yes.
open to questions if you have any.
Yes, sir. Actually, pictures were very useful.
Now the floor is open for a Q&A session. So if you have any doubt, you can clarify now.
Okay, looks like my session was tough.
No, sir, it's very interesting. Okay, now I think a heartfelt thank you for you, sir, and for sharing your invaluable insights on smart manufacturing in the automotive industry, specifically with Maruti vehicle. Your expertise has been enlightening, and we are grateful for the knowledge that you have imparted for us. Your enabling ability to explain very complex concepts like e-nagare, the Anton button, with very relatable examples like the sorted chocolate boxes, the metaphor which you used, have means it's very easy for non-engineering participants to understand these concepts. So we really thank you, sir, for this enlightening session. And to be honest, that your name in the resource person list has added value to this FTP as well. So thank
Okay,
you,
I hope
sir.
so. Yeah.
Thank you, sir.
Okay.
Thank you so much,
Thank
sir. Thank
Yeah.
you.
Bye.
Participants, with this, we'll be concluding today's session. We'll see you on Saturday, that is tomorrow, 6 p.m. I'll be sharing the link shortly here.
Your voice is very low, ma'am.
Maya ma'am, your voice is very low. It's not audible.
Can you hear me now?
Yeah, yes, ma'am.
Yeah. Okay. I'll be sharing the link now. Please be connected.